Welcome. In this lesson, we're going to actually start having you evaluate logarithms, and I would like you to try to do it without a calculator. So remember that a logarithm base b of some number n will equal some number or our exponent. So what I recommend is converting it or changing this expression back to the exponential form, and that will help you see what it is. B raised to what exponent is equal to the number that we're taking the log of. So here I would do 6 raised to some unknown number equals 36. Well, that's an easy solution. We know that 6 squared is 36. So guess what that equals? That equals 2. Just like that. And all of these will be very, very similar to that nature. Again, 9, that's my base, raised to some unknown number, that's the number I'm looking for, will equal the number I'm taking the log of, 9. Well, 9 raised to what power is 9? Well, that's 1. So the solution is 1. Again, and that's weird that that's not, there we go. A lot of these I just do very quickly in my head, but I again recommend that you write it down if you don't. But 2 raised to what power is 2? Well, that's 1 again. 2 raised to the 1 power is 2. 7 squared is 49, so I'd put a 2. 7 is my base. 7 squared is 49. 6 squared is 64. Remember, if you don't see a base and it's log, it's base 10. 10 raised to what power is 100? Well, 10 times 10 is 100, so it took 2 10s. 4 raised to what power is 64? It's not 2, it's 3. 4 times 4 times 4 is 64. It took 3 4s to multiply together to get to 64. So that's another way you can think of it. We have a base 10. How many 10s do I need to multiply together to get to be 10? Well, I need 1. How many 5s do I need to multiply together to get to 625? Well, I believe that's going to be 5, I believe. Let's see. Nope, it's 4. I was off. I knew I was off when I was... How many 10s do I get to 1,000? Oh, that one's easy. It's just the number of zeros you have. That's 1. That's 1. So a lot of these are going to be very simple. That's 2. That's 4. I know that takes 4 times 2 times 2 times 2 times 2, 4 times to get to 16. That one I have down. Okay, now this is our negative exponents. I'm glad we made it to this. I have a base 10. Now again, remember, write it out. Base 10 raised to some exponent x is going to equal 1 over 100. Remember our negative exponents? Our negative exponents drop it to the denominator. So what's going to happen is we're going to need a negative 2 exponent. The negative drops the 10 down, and we square that. It's 100. That makes it 1 over 100. So we're going to start getting negative solutions. Same thing here. It takes 3 4s to get to 64, but it's in the denominator. It's a negative to bring it down. Ooh, now here, again, if it helps, do 1/7 in parentheses raised to some unknown exponent is going to equal 1 over 49. Well, that's just a positive square it. 1 squared is 1, 7 squared is 49. So our actual solution is just a positive 2. Again, this will be a negative 1. Why is it negative 1? Because 10 raised to what power is going to be 1/10? And remember, a negative exponent, 10 to the negative 1, well, that 1 over 10 to the 1 power, that's 1/10. That's what we want. So you might need to go back and review your negative exponents. Ooh, this one is a root. What I mean by a root is this. We take 625 we raise it to some exponent, and we want a smaller number. We want 5. Well, that's the root. We did this one earlier, and I thought the answer was 5, but the answer is 4. In other words, 625 raised to the 1/4 power is equal to 5, or the 4th root of 625 is 5. And that's what it's asking for. It's asking for what root must I take 625 to get it to be 5? Well, it's the 1/4, or it's 1/4 power, because we write it as an exponent. 1 over, not 1 1/4, 1/4. Again, 10 turned into a fraction, it's going to be a negative exponent. It takes -3 of them. Again, 1/5. Again, write it out if you need to. It will help you keep track of your signs. Equals 625. Well, I want the 5 in the numerator, not in the denominator. I'm going to have a negative exponent. Negative exponent is going to flip that fraction upside down. So I flip it upside down by using a negative exponent. And how many 5s does it take? 5 times 5 is 25, times 5 is 125, times 1 more is 4. So is that 4 again? -4. Again, same exact process here, -2. If you have any more questions, bring them to class, and I will help you at that point.